Hi everyone and welcome back to PrepFusion. I'm Anish and today we will start the lecture 1B of our complex power chapter. So mainly we will discuss about the homework problem, and also I gave you one homework that to derive the expression for the RMS and the average value of a triangular periodic waveform, and a few more questions we will discuss. So this was the first question, which was the very simple question that I have given you as homework. So here what you needed to find out, you basically needed to find out the uh, instantaneous power and the average power. So my voltage signal is this and current signal is this. It is a formula of sin A sin B. So of course you can derive the formula for sin A sin B. You can write down the formula, but we have just derived in the previous lecture and we know what is the value. So I also don't remember the value. Okay, if ever I forget, I will just use the formula. 2 sin A sin B is equals to cos A plus B minus cos A minus B. Sorry, cos A minus B minus cos A plus B. That's it. I will use that formula. Okay. So, but I already remember the formula, that is Vm Im by 2. That was the actual active power, cos theta V minus theta I minus Vm Im divided by 2 cos of the addition of the two angle. This is the subtraction of the two angle, and inside this is the addition of the two angle, theta V plus theta I. Okay, so yeah, now you can obviously put the values. What is my theta V? Theta V is with respect to the reference, it is 20 degrees. Okay, what is my theta I? What is my theta I? Theta I is basically equals to plus 60. Is it? Is it so? If you are writing it like this, that means you are writing it wrong, because this is cos, this is sine. So at least have a common reference. At least have a common reference. So let me convert this cos into sine. So this will be 330 sine of 10t plus 90 plus theta. So it is plus 20. I have already explained how we write it in terms of sine. So ultimately the actual function, this comes out to be sine 10t plus 110 degrees. Okay, 110 degrees, that's it. That's basically it. Okay, so this is the case basically. Now let's, what is theta V now? What is theta V? Theta V is 110 degrees. So from here I can directly write my expression for the instantaneous power. This will be Vm Im. So Vm is 330, Im is how much? Im is 33 divided by 2. Okay, then it is cos of theta V minus theta I. What is theta V? Theta V is 110 degrees minus theta I. Theta I is 60 degrees. Okay, so all these are questions of Cedra Smith, sorry, not Cedra Smith, Alexander Sadiku. Okay, I have taken few questions from Alexander Sadiku. So this is minus the same thing only, 330 into 33 divided by 2 sine of, sorry, cos of 2 omega t plus theta I plus theta b. It is 110 plus, what is theta I? Theta I is 60 degrees. So this part is wrong actually. Theta v is equals to 20 is wrong. So this is 20 degrees plus 60 degrees. Okay. So this will be basically 330 into 33 divided by 2 and cos of 50 into cos of 50 So it will be 3, almost 300 and 3500 watts, and 330 into 33 divided by 2 into this cos, the cos of what, cos of 80. Sorry, this should not be, sorry, this should not be 20, right? I made the same mistake. This should be 110 degrees. Okay, so this will be 170 degrees. This will be 170 degrees. So this will be 330 into 33 divided by 2. So 5445 cos 2 omega t plus 170 degrees. Okay, so what is the active power? Active power is this average value, right? Simple average value. If you take the average, it will simply come out to be 3.5 kilowatts. So this will be P average will be equal to 3.5 kilowatts, and this will be the answer of my question. So this is one of the answer, instantaneous power and the average value of the power. So now I will derive for the triangular waveform, the average and RMS value of the triangular waveform. So average is not that difficult. Basically, what is average? Average is basically the area divided by the time period. It is a periodic waveform, so it is simply area divided by the time period. That is also another way to find out the average. So x average equals to area divided by time period. So what is area? Area is half base into height. Base is tau, height is e. So it is half a tau divided by the time period. What is the time period here? So right, time period is t. Okay. Currently, I have not provided you with any relationship for the time period and the tau. So currently the time period is t. If none of the relationship has been provided, it will be simply a tau a by 2 tau by capital T. Okay, and if there is some relationship, generally if this triangle is basically symmetrical, that means its capital T or tau will be the half of the whole time period, correct? Capital T will be t by 2. That's it basically. So you can directly write this one. If this relation is following, then I can directly write a into capital T by 2. Ultimately tt will get cancelled, it will be a by 4 only. So this will be the average value basically, and it also makes sense, right? It also makes sense because obviously your a is more towards the lower side rather than on the this is a by 2, right? So I can see more area below a by 2 than above a by 2, so ultimately it will pull it down. Okay, that was for the average value. Now let's discuss for the RMS value. What will happen to the RMS value? So for the RMS value, we have to use bit of formula. So this I can delete basically. Formula meaning basic integration. We have to do basic integration. So just hold on a second. I will check the mic. Yeah, I was just checking the mic whether the voice levels are okay or not. So for RMS, what do we do? First, we take the square. So I am only calculating between 0 to tau because, like, let's assume it to be symmetric about tau. So obviously for tau to capital T, it will be same only. The area will be same. I will just multiply by 2. I will just multiply by 2 because if it is symmetrical about tau, whatever is the area here, the same area will be here only because it is symmetrical about tau. So if I do x square, this will be a square into t square tau square. Okay, so then what we do, then we take the mean, right? So as I have told you that it is like area is symmetrical, so what I can do, I can just calculate the area till tau, and then simply multiply by 2. If I just multiply by 2, calculate the area till tau, and that will be enough. So this will be equals to x square, like the area from 0 to the time period t, x square of t dt. Then what I will do, then I will divide by t. Okay, I will divide by t. So that is it. So this will be equals to, this will be equals to uh, ultimately what will happen, this will be 2 by 2a square by capital T, and tau square is of course there, and my T is what, currently my T, as it is symmetrical, right? Okay, have I done something? Either you can write it in terms of tau is t by 2, yes, tau is t by 2, that is correct, or this is 2 tau, anyway works. So here what I will say is T is equals to what, 2 tau, correct, as it is symmetrical about tau. So this will be from 0 to t square. So this integration will be t cube divided by 0 to tau. Okay, so this will be basically tau cube tau t. So this will be t only, this is tau square, so tau will get cancelled, and this is okay, this I can replace, right? This I can replace with 2 tau. So 2 tau will get cancelled here. Ultimately this will come out to be e square divided by 3. Okay, and what is the RMS value? RMS value is ultimately the under root of this, right? So my x RMS is basically the under root of this thing, x square t. So that is equals to a square by 3 whole under root. So it will be a by under root 3. Okay, so this will be the basically answer of this particular question. So that's it about the homeworks. So now we will start with the assignment question. So first what I will do, I will just show you all the questions that we will solve in this lecture. I want you to try, then I will solve. Okay, these are all the questions. These are mainly like the book, from the book of the Alexander Sadiku. So all of these questions are from the book of Alexander Sadiku. Okay, just pause the video, try all the questions. So this is the last question, I think 34 is the last question. Yeah, 34 is the last question. So all these questions are from the book of Alexander Sadiku. So if you want to, like, there is no need to read the book, but if you want to solve questions, you can solve the unsolved ones. But I will recommend not to solve anything. Whatever we teach in the course, that is more than sufficient, and you will not be able to finish that within your time. You will not be able to finish that. Okay, so I will come back with the solutions. Yeah, so actually what happened was I recorded the whole video, like I was recording whole questions and answers. At the end, when I was trying to edit the video, I saw where is the file. The file was not present. Actually, I forgot to press the recording button. So again, I have to re-record basically the question part. So 3 questions or 4 questions I have given you homework, the assignment question, right? That I have to re-record. So yeah, it's our life. What you can do. So as I was saying, let's start with this question. This question is not that difficult. So first we have to find the RMS value of the current waveform. So this is a simple triangular waveform. What is the RMS value of a current triangular waveform? It is A by root 3. That is the RMS value. What is the A in this case? A is the peak amplitude, that is 16. So this will be 16 by root 3. This is the RMS. This is the IRMS basically. What about the other thing? The current flows through 9 ohm resistor. The current flows through 9 ohm resistor. Calculate the average power absorbed by the resistor. So I have written a point that, like, another definition of RMS is that, like, here I have written, what is that? Yeah, if I have an AC source and I replace that same AC source with a equivalent DC source with magnitude equal to the RMS value of the AC source, then it will deliver the same power. That is also another physical significance of RMS. What did I say? I said I have a AC source. The source, if I replace it with a DC source whose amplitude, whose magnitude is equals to the RMS value of the AC source, then both of the sources, AC and the DC, separately will deliver the same amount of power. That is also another important definition of RMS. So I have got the RMS value, and if I connect a DC source with the RMS value across a resistor, whatever power I calculate from the DC source, same power will be delivered from this AC source. So basically, this is the DC source plus minus IRMS, and here is the resistor. Here is the resistor R. So simply, what will be the power loss? Power loss will be PR will be IRMS whole square into R. So what is IRMS whole square? IRMS whole square is 16 whole square 3 into 9. So this will be equals to 16 whole square into 3. So this is basically 16 whole square into 3. So this value will be 16 whole square into 3, 768. 768 watts will be the answer. Pretty straightforward and simple. Let's move on to the next question. So in the next question, yeah, this is the next question where again we have to find out the RMS value of this waveform. Also, we have to find out the average power dissipated in the resistor. So this is a new waveform for us. So we will dive a bit more deeper. We will also derive the expression for average value because I have not derived it previously. So few standard waveforms are there. Those I will teach you what are the average values. Those you can remember, and all the other things, right, you can derive. I will tell you how you can derive from this basic fundamental waveforms the other values, RMS and average of other waveforms. That I will discuss. So let's first discuss about the average value of this. So this is a rectified sine wave. What does a rectified sine wave means? Basically, a sine wave is like what? Initially from 0 to pi it is positive, from pi to 2 pi it is negative. That's it. That is what a sine waveform looks like. So what I can say is this, right? It's not exactly a sine, because from 0 to pi it is exactly like a sine waveform only, but from pi to 2 pi this is not equals to sine. So what is it equals to? My sine was negative, but this is just the opposite, right? So it is minus of sine. So basically, if I have to give a definition to my waveform, my x of t will be equals to Vm sine omega t from t equals to 0 to pi, then it is equals to minus Vm sine omega t from t equals to pi to 2 pi. Okay, so that is the case. That is the case over here, what you have to understand. Now what I can say is that uh, I can notice one thing, that a sine wave has a period of 2 pi, but this has a period of what, pi, because I observe that after every pi this waveform is repeating. So I don't need this definition, actually only this much is sufficient to calculate what, to calculate the average value. So if I want to calculate the average value here what is the omega basically here, right? At omega t equals to pi, it is going to 0. So basically my omega is 1. Omega in this case, for this particular waveform, is simply 1, because at omega t equals to pi, I am getting 0, and 0 happens when sine pi, when the angle of the sinusoid is pi. So yeah, it is 1 only, it is simply 1 only. So basically what is my x average? X average will be integration from 0 to pi 1 by pi, because I am dividing by the time period, because now the time period is only till pi. Vm sin t dt, okay, Vn sin t dt, this, or I can write d omega t as well, that is totally fine, because yeah, we are going from no, this is fine, 0 to pi is fine, okay, because here, right, remember they have provided the time axis, so the axis here is time, it is not omega t, so that's why I am integrating with respect to time, I am not integrating with respect to omega t. Whatever is the axis, that you have to take care, right? What is the axis here? With respect to that only you integrate, correct? Whatever is the x axis, with respect to that only you integrate. So that's why this is 0 to pi sin t dt, and the integration of this is very simple. Vm by pi is outside, minus Vm by pi, and this is cos t from 0 to pi, okay. So this will be equals to what? So this will be minus Vm divided by pi, cos of pi is minus 1 minus of 1. So ultimately this will come out to be 2 Vm by pi, okay. The value will be 2 Vm by pi. This will be the answer of this question. The not answer, sorry, this will be the average value. So what you have to remember is like this. If you remember, it's good, because this will be used in multiple cases. For a rectified sine wave, the average value is 2 Vm by pi. If you remember it, that's good, okay. Now can you tell me, what if my waveform was somewhat like this? Let's say it is somewhat like this. From 0 to pi it is there, and then from pi to 2 pi it is 0, okay. So omega t. Now what if my waveform is something like this? Pi to 2 pi. So can you tell me the average value of these things? So basically, right, here what has happened, this area from 0 to 2 pi is the same, right, this 2 Vm, but the time period has changed now, because I am dividing by 2 pi now, because it is periodic after every 2 pi. So average value for this waveform, you can calculate, obviously you can mathematically calculate, the average value will be 2 Vm by 2 pi, basically it will be Vm by pi, Vm by pi. For these waveforms, average value will be Vm by pi. If you remember this thing, of course you can derive, it will hardly take you 30 seconds, but it's good to remember these results, because this will get used multiple times in lot of places. Now there is another short trick. Let's say I have a sinusoid like this. I've already told you how to find out the average value of a half sinusoid, basically, which repeats over a period of 2 pi. So this, right, is basically, this is what, this is sum of two sinusoids whose peak amplitudes are different. This will only work if frequencies are same. So here frequencies must match, must match, frequencies must match. And what shall change? Your amplitude can vary, amplitude can vary. Okay, so now what you can do is individually I can find out the average of this, and then I can add these two, because these are totally orthogonal, right? These are totally orthogonal. That's why, like, one of the signal is this one, other signal, let's say, is this one, right? So I can individually add the averages as well, because individually there are sums. So if I take the average as a whole, the average will also be a sum. So what is the average of the first one? Average of the first one I have already derived. Is what basically I am talking about this signal, only this signal. What is the average? Average is 2 Vm by 2 pi. This is the average basically. Plus, what is the average of this signal? It is minus 2 Vm, okay, because it is negative. Remember, it is negative. Minus 2 Vm, of course, will be there. Multiplied by 2, because I always multiply with a factor of 2 with the amplitude. Divide by the, like, what is the waveform here? The waveform is something like this, correct? This is the waveform. This is the waveform, okay, and this is the top waveform. I hope you are understanding. We're just adding the two waveforms. So this will be divided by 2 pi. So ultimately your average value comes out to be something negative, which is understandable as well, because in the when it is in the negative time period, the peak value is higher than the positive period, right? Of course, the area will be totally negative. Area will be totally negative, okay. Minus 4 Vm by pi 2 Vm, okay. Vm by pi and minus 2 Vm by pi. So what does the final value comes out to be? Final value comes out to be minus Vm by pi, okay. So yeah, that is the answer basically. That is the answer in this particular question. So not answer, it's a short trick that I wanted to explain, because these kind of waveforms will come in examination, right? We have not even got to the answer. I don't care about the answer, but I care about the concept, right? So these kind of questions can be asked in the examination. That's why we have to, like, understand the tricks. So this is how you can solve individually. Individually, you know the waveform average value of this. Individually, you know the average value. What you do, you just assume the other part to be 0, and then you add the averages, okay. This was for the short trick of this particular case. Now let's come back to our question. Basically, we have to find out the RMS value. So we have not found out the RMS value. So RMS value, right, will be same as a normal sinusoid. Why will it be same? Why will it be same? It will be same because if I square this, right, if I square a normal sinusoid, what will happen? It will also be always positive. If I square a rectified sine wave, it is anyways always positive. So after squaring, right, everything is anyways same, which I can prove it to you as well. Mathematically, I can prove. What is RMS? RMS is root mean square. So first I will square the waveform. So my RMS value is XRMS or IRMS in this case. IRMS is 1 by pi, because it is after I square it, right? Anyways, it is repeating after we pi only. 1 by pi integration 0 to pi I square t d t, because the axis is time axis. Okay, what is I? I is 100 sine t, right, from 0 to pi. So basically what I get? I get 100 square by pi, 0 to pi, sine square t dt. Okay, so what is the integration? Very simple, right? Again, you can convert this sine square t into your normal cos to omega t formula. So this will be 100 square divided by pi, 0 to pi, 1 by 2 minus 1 minus cos 2t dt. So this will come out to be, so ultimately, right, this one is anyway 0. Why? Because what is the period of this? The period of this is simply pi. The period of this is simply pi. If the period is pi, simply I am integrating over a pi only. So automatically, if I integrate any cosine or sinusoid over its period, its integration is 0. So this is the only remaining thing, that is half into pi also will be there. So basically it is 100 square divided by pi into pi by 2. So this will be 100 square divided by 2. So this will be IRMS. IRMS equals to 100. Basically I have to take the under root as well, right? I forgot to take the under root, I'm sorry. So everywhere there will be a under root. There will be a under root everywhere. Okay, so basically it becomes 100 by root 2. So which is the same result, right, which I discussed. Like basically what is the RMS value of any sinusoid? Vm by root 2. Same is happening here, Vm by root 2. So like we did so much of work. So our power will be what? Power will be IRMS whole square into R. So IRMS whole square is 100 square divided by 2 into R. R is 6 ohms, I think. R is 6 ohms, yes. R is 6 ohms. So this will be 10 raised to power 4 into 3. So 3 into 10 raised to power 4, or am I correct? RMS 100 by root 2, just 100 by root 2 into R. Yes, it is correct only. Yeah. So, oh, I am extremely sorry. Actually, it is the voltage signal. I am extremely sorry. This is not the current signal. It is the voltage signal. So, sorry. This is not the current. Sorry. This will be the voltage signal, correct? So, this will be voltage. VRMS V square. So this will, right, this is not IRMS, this is VRMS. So for VRMS, what is the formula? For VRMS, the formula is simply what? V square by R. VRMS whole square by R. That is the formula for power. So what will come here? It will be VRMS whole square by R. So it is basically 10 raised to power 4 divided by 12. So 10 raised to power 4 divided by 12, 8, 33, 0.33 watts. Okay, so this will be the answer of this question. So let's move on to the next interesting question. So this is also a very interesting question, where you have to find the average and RMS value of a given waveform, which is not a standard waveform, right? I know the triangle, I know the square, but I don't know what is the average or RMS of a triangle and square. So what you will do, you will break this waveform down. You will break this waveform down into two formats. One is the simple triangle, another one is the square. So as I have mentioned in the previous question only, right? So I will individually find out the average and then add, because all of these are orthogonal. If these are orthogonal, so I can do that. I can do that. If these are orthogonal, I can do that. So individually, what is the average of this? Average is what? Average, x1 average is what? area divided by the time period. What is the area? It is half base into height, simple triangle, right? So half into base is pi into height is Vm. So half base into height is Vm. And what is the time period? Is simply 2 pi, because it is repeating after every 2 pi period. What about this one will be equals to what? This one will be Vm by 4 simply. That will be the average value here. What about the other part? What about this part? That is the square part, square portion. So for the square portion, this is Vm, right? Yeah. So for the square portion, again, extra average will be what? It will be area over the time period. Area is what? Height into depth, right? This depth into height. So this will be Vm into pi divided by 2 pi. Basically its time period is also 2 pi only. Its time period is also 2 pi only. Okay. So this value will come out to be Vm by 2. Okay. This value will come out to be Vm by 2. So ultimately what will be your final result? Final result will be basically, this is attributing to some positive area, this is attributing to some negative area. So ultimately I visually what I can see is negative area is more than positive area. Of course average also will be somewhat negative, because negative area is more than the positive area. So average will be minus Vm by 4. Basically if I add, right, what is the overall x average? Overall x average equals to x1 average plus x2 average. Okay. So that is the answer of this particular question. So I hope you have, like, not answer, sorry, this is the average value. Of course we have still, we are yet to find the RMS value. So we have to discuss about RMS. So for RMS, right, what I observe, if I take this waveform in the next page, this was the average one basically, this was the average one. For the RMS, what we observe is, for RMS, what I observe is basically it is a orthogonal signal, right? If it is a orthogonal signal, if let's say x is equals to x1 of t plus x2 of t, and I know that it is orthogonal, that is x1 x2 x1 of t into x2 of t dt, integration is 0. That means what? That means that I can simply write down this relationship, that is x RMS equals to x1 RMS whole square plus x2 RMS whole square. Okay. So I will be able to do this simple thing. What is the RMS value of this? Now this, right, I have not taught you how to find out the RMS value of this. What have I taught you? The RMS value of this waveform, right? This I have taught you. For a simple triangle, I have taught you the RMS value of a simple triangle, correct? This we know. What is RMS value? This is a, let's name this signal as y of t. So RMS value, y RMS is equals to what? It is a by root 3. This we have derived, right? This is simply what? Tau, this is t, and I know this tau is simply t by 2. We have derived in the today's lecture only, a by root 3. Now what is RMS value? What is RMS value? RMS value is basically the integration of over the time period of y of t dt, y of t whole square dt whole under root. Correct? This is what my RMS value is. Now if I want to write few things, Let me take square on both sides. If I take square on both sides and then multiply by t on both sides, the time period, I will get this a square by 3 into t equals to integration from 0 to t y of t, y square of dt. So this is the result that I get. Okay. Now can I apply something here? Because I need to find out RMS of this waveform. To find out RMS, I ultimately need to take the square and then find out the area over that region. This tells me the area over that region. This relation tells me the area of the square of that waveform over that region 0 to t. So for this triangle, the squared area is a square t by 3. Can you tell me, if I have a half triangle like this, what will be the area of the square? It will be simply half. It will simply be half, because for the other part it is 0, and for only one part I am getting the area. If I square it, the other part will still remain at 0, and the square and this square will be identical for 0 to t by 2. Both of this will be identical for 0 to t by 2. So ultimately this area I will not get, only this much area I will get. What is it equals to? Simply half of whatever I am getting. So my integration of x1 of t whole square dt from 0 to 2 pi, this will be simply half, because the other half is simply 0. So ultimately this will be equals to a square by 3 into t is there, that is 2 pi. Okay, the time period of the waveform, divided by, sorry, the time period, no, this will not be, this will be time period only, into 2 pi, yes, into 2 pi, yes, 2 pi divided by half, I mean multiplied by half. So this whole thing will be multiplied by half, the area will be simply half. Okay, so now what I can say is, this will be, so what will be my RMS, x1 of RMS? So my x1 of RMS will be equals to 1 by 2. Now I know the area, right? I know this area. So what I have to do? I have to divide by the time period. I have to write the area expression, x1 whole t square dt 0 to t, and then I have to take the whole under root. So this portion I know. What is this portion? This portion is here. This portion is here. So I can replace, what is t, time period is 2 pi, and this is simply 1 by 2 into a square by 3 into 2 pi, half. Okay. So this will be, this will be simply a square divided by 6 whole under root. So this is the RMS value of the first waveform. Second waveform is rather simple. You will simply be able to find out the RMS of this. It's not that difficult. I hope it's not that difficult. What is x2 RMS? X2 RMS will be very simple, right? What is the area of the squared? So if I square this, right? If I square this, what will happen? This will be Vm square basically. The waveform will be something like this. Vm square, for the other half it will be 0. So x2 RMS will be what? If I write the area, it will be Vm square into the width. Width is 2 pi minus pi divided by the time period, that is pi, so 2 pi. Okay, that is the area average, and then if I take the whole under root, so it will simply be Vm square by 2 whole under root. So what I have to do, ultimately my whole RMS x RMS equals to x1 RMS whole square plus x2 RMS whole square. So ultimately my XRMS will be equals to this will be a square by 6. A in our case is Vm, right? A in our case A is simply Vm. So this will be Vm square by 6 whole under root. So this will be Vm square by 6 plus Vm square by 2 whole under root. So yeah, so the values, this value will be 1 by 6 plus 1 by 2. So this is like 3 4 by 2, or no, 3 by 2. No, this is 3 multiply 4, 2 by 3. So ultimately this will be under root 2 by 3 Vm. This will be the answer of my question, the RMS value. Okay, this will be the result basically. So what is the important point? What is the key point here? The key point is hidden here. The key point is hidden here. Okay, so RMS value has lots of information if you are able to extract the correct information. So obviously everyone teaches the same subject, right? But it's important whether the educator tells you the important information, what you have to keep in mind. So in this case, what we have to keep in mind is that I know the definition of RMS. The definition of RMS, XRMS equals to 1 by t integration of 0 to t x square of t dt whole under root. This definition I know. Okay, now from here can you extract something? I can find out the information about the square of a waveform, about the area of a square of a waveform if I know the RMS. Okay, and then from there I can go back to some other waveform if its area has been halved, or if it is 0 for certain periods. So basically the important equation here is from 0 to t x squared t dt, that is the area of the square of the waveform, will be simply equals to XRM. If I square the both sides, XRMS whole square into t. This is a very important thing to like, no need to remember. Of course I have told you the definition, and from the definition if you are able to extract the information, you will be able to find out the RMS value of the waveform. Okay, so now let's find out the RMS value of this waveform. So this is rather simple. Here the two signals, both the signals are what? Are orthogonal to each other. Orthogonal meaning their integration x1 x2 over the time period is 0. So simply I can use the RMS formula. What is the RMS formula? My V of t, V RMS, I can write as V1 RMS whole square plus V2 RMS whole square whole under root. Okay, so that is the case over here. Now of course, what is V1 RMS? V1 RMS is in this case, what is the V1 RMS? It is 2 by root 2, right? 2 by amplitude by root 2 RMS whole square plus 4 under root 2 whole square whole under root. So this will be 2 plus 8 whole under root. So this will be 10 whole under root. Okay, so this value will come out to be 3.27. Something somewhat like that. So this will be the answer of this question basically. This will be the answer of this question. Okay, so yeah, that's about it for this lecture, and from next lecture onwards we will start with the more in-depth analysis of complex power. What are the different components of power? We will see active, reactive power, all those things we will see. I hope you have enjoyed this lecture. If you did enjoyed a particular portion, make sure to comment below that particular timestamp what portion you enjoyed, and of course make sure to like the video, and I will see you in the next lecture. Until then, happy learning.